As you may already know, I produce vintage boards and parts for old computers and test equipment. And in a previous video I mentioned that as I released each new board, I would post a quick video to introduce it, go over any assembly issues and test issues. And this is the latest one. It is for an Altair 8800. It's the 8816K static RAM card, so it's a 16K RAM card. I only supply it as a bare board, but I will demonstrate it in this video to show that it works, and also to quickly go over the assembly. Assembly is very straightforward. The only thing I would suggest is looking at the parts list, where it lists 74L04s, which are hex inverted buffers. I would suggest replacing those with 74LS14s, which are the Schmidt trigger version of those devices. It just makes the board a bit more immune to noise. Having said that, the board I'm going to demonstrate today has the 04s fitted, so I only supply the bare boards, but I will demonstrate a fully assembled board. So this is what they look like once they're assembled. It's very close to the original design. The layout is pretty much exact. It's within a small fraction of a millimeter. It uses the Semi 4200 SRAM chips. You can populate it in banks if you want to, so it's arranged in 4 banks of 4K. So these are 4K by 1-bit devices, and each vertical column is a separate 4K bank. So in other words, you could fit just the right hand 8 devices, and that would give you a 4K card, or you could fit 2 banks, etc. So for each 8 devices you fit, you get an extra 4K, and you can put up to 4 of these in a single Altair. The dip switches at the top right allow you to select what the address space is that the card will occupy. So obviously there are 4 switches, you put just one of them on. Starting from the left, that'll put it at the lower 16K, and then working progressively upwards you have just one of the switches on to decide which 16K block you want the board to occupy. Assembly is very straightforward. There are no workarounds, there are no modifications that you need to make to the board. All the parts, other than maybe the memory chips, are easy to get hold of. For the memory chips, they are available, and I didn't have much problem finding enough for the 4 boards that I intend to make. Okay, so that's the board. I'll get hold of an Altair and plug it in and show you how I go about testing it. Okay, so I have the board plugged into an Altair. I have it configured to occupy the lower 16K of the memory address space. So I'll start up the Altair, give it a reset. Now when you're testing the board, you can test it from anything from a single chip right up to the whole complement of chips. It's entirely up to you as to how much confidence you have and how expensive your memory chips were. If you want to test it single chip at a time, then what you can do is put in just the lower bit device. Bear in mind these are 4K by 1 bit, so each chip provides 1 bit out of the 8 for each block. So if you fit just the lower bit, then you would be storing and testing just bit 0, and then you can incrementally insert each additional device and then test each bit separately. The lower block is on the right, and then going up incrementally for each of the subsequent 4K blocks. I tend to test them in blocks of 8 devices, so 4K at a time, but it's entirely up to you as to how you go about testing. But what I tend to do is, when I first assemble the board, I'll put in the first bank of 8 chips, and then I will try loading and retrieving some simple data from just a few addresses to make sure that the board is fundamentally working. So we'll start at address 0, reset, and we'll make sure we're looking at the first address space, deposit 0, and then just go through just maybe 20 addresses, setting them all to 0, and then we'll go back through and examine them to make sure that they are all set to 0. If you're doing one chip, then obviously you can only test one bit at a time, but if you're doing all 8, then you can now set a pattern that you want to store, deposit that, and then same thing, just go through and then examine to make sure that they're all stored correctly, and then do the reverse, and then you can go through that. As you can see, this is working. If it's not working, then it's very clear that it's not working. So I'll demonstrate the sort of thing you'll see if it's not working. If I select an address outside of the memory space that the board is occupying, and then try to do the same thing, so we'll try and set all zeros. Make sure we open the address space. And you can see it hasn't stored zeros because there isn't any memory in that area. And if we go back to the location that we were, you can see that we have the data showing as it should do. Okay, so that's fundamental testing, just to make sure the board is working. If you encounter any problems here, there's no point trying to go any further. You need to resolve what's causing the problem. Okay, so what I'll do now is I'll load BASIC. I've got the terminal program showing in the corner of the screen, but what I'll do is toggle in the first stage loader, and then I will send the second stage loader, and then I'll send BASIC itself, and we'll see if it runs. So firstly, I'll toggle in the first stage loader. I'll probably fast forward through this bit to make it a bit less tedious. Okay, so that's the first stage loader toggled in. I'll just go back and examine it to make sure that it's error-free before I try to run it. Okay, so that's all correct. Next step is we'll reset it, and I'll set the switches to indicate the sort of serial card that I have. I'll now go over to the terminal program and send the second stage loader, and just get the Altair running. Lights look good so far. Okay, so as you can see, the second stage loader is running. The usual value is showing on the bottom row of LEDs, so we should normally expect to see is a value of 7647, which is what we have. I'll now go back to the terminal program and send BASIC to the Altair. So as you can see, basically it's up and running. It's reporting the correct memory size, bearing in mind that BASIC itself is taking up some space. So it's a good sign that the card is working. I'll just do a very quick simple test program just to make sure that it's running as we expect it to. Okay, so as we can see, the Altair is running fine, no problems, it's not crashing or doing anything strange. I have tested this board fairly extensively, and I'll be running further tests over a period of time. I'll be fully populating this machine with a set of 4 of these boards and then running that as well. But the board works fine, it's very reliable. One thing that's very noticeable when you run it is how little heat it gives off. If you're familiar with most memory boards for the Altair, they do get very hot, and some of the memory boards I have get almost too hot to touch. But this it's almost cold, it barely gets warm at all, which is obviously very good, and especially when you come to adding more of them. So just pop the board out so we can have a final look at it. So I'll stop the Altair from running, switch it off, then pop out the board. Okay, so if you have any questions about this board or need any more information, then please let me know. They're available on the JM website. As I say, they're only bare boards, you'll have to source the parts and assemble them, but do make a really good addition to an Altair.